So I thought I'd do a little update video. I wasn't going to do one really until I got these coils wound, but yeah, I thought I'll just move everything out of the way as a minute. So I'm winding these are the coils. These are a bit chunkier because these are the coils which go on top with the ferrite rings that go through the middle, and I'll just get another bobbin to show you. So these bobbins are larger and they're more closer to the original coils that I had in there, which were round ones, if you remember, the ones that melted. Let me just grab them, hang on. Which worked very well. Oops, damn curtain. Wires got hooked on my curtain. Right, so these coils are the ones which I was using, which melted, if you remember, and these work very well. And I originally had the concentric magnets on the back. Well, the actual thickness of these coils, which I also own with a coil winder, is the same. So if I get this new bobbin, which is rectangular instead of round, and put it next to that one, let's see if I can do this. If I put it side by side, you'll see that it's the same height. So because it takes two ferrite cores in the middle. The reason I'm using the rectangular ones is because it's more in alignment. The flux is more in alignment with the actual magnet drums, and it's going to be a two-layered system. Now, magnet drum. Here's a magnet drum. I'll stick this here. You'll see that the coil is the same width as the magnet drum. It's actually exactly the same width, so it should give me and the coil in the middle is where the flux is focused down the ferrite cores to the drum. So these will be more efficient, I'm hoping, than the round ones were. So I mean, a lot of this is fine-tuning. This is what this is all about right now. It's fine-tuning. Now I've got the new double-decker draw section made. I'll just lift my light up a bit so you can see a bit better. So I've been winding the new coils, which are going to go in the top section. So if I just move this thing out of the way a minute, and move my rings out of the way and pull the drawer out if I can. It's a bit difficult. Oh, before I pull it out, look at the alignment. I've actually got ball bearings at the base now instead of at the top. I'll explain that in a minute, because there's magnets in the base now instead of on the top. So instead of having concentrics, I have a rectangular arrangement of magnetic flux reserve in the bottom of the draw section, and I've got my rubber feet on. Oh, I love my rubber feet. I'm made out of silicone rubber, actually. They keep falling out, but they're alright. They're easy enough to put back in again. Right, let me get this out. It's a bit hard to do it with one hand. I need to push the other side, actually. Let me just go around here, push the back. Just push the back a bit, so I don't take it all the way out. I just want to take it so far out. You can see the ball bearing, the bottom. There's a bottom coil now. There's a coil at the bottom. That's the bottom draw section down here, and there's going to be a coil on the top section. So it'll be a double-decker coil system, and these bobbins will just slot in like that, and it'll have ferrite cores in. Sorry, I don't want to put them in actually. I just want to show you that I'll put these inside there. So this should improve the actual gain, and because there's two separate coils, I can either wind them in series with the coils at the bottom, or I can wind them in parallel, depending on whether or not I want to use a higher voltage to drive the circuit or low voltage to drive the circuit. The purpose of having two coils is to focus. Imagine a lens on a camera. It's all about focusing that flux at a certain, you want to keep the flux tight so that it's in a straight line, and it's like like a pencil focus to the drum, so you get better traction on driving it, because these are the drive coils, you see. So by having just one coil, the flux will be wider. The flux field will actually be wider, so it'll spread out more, whereas having both coils on, the flux will be tighter and it'll be longer. So that's the effect you get with a magnet, just an ordinary magnet. So if I get an ordinary magnet, it's exactly the same principle, no different really. So let me just go and get my viewing film a minute, and I'll show you what I mean. Right. Right. Everything's falling over. Right, there's my viewing. Let me just get my viewing film out, and I'll show you what I mean. You can simulate the same effect with just static magnets anyway. So, right. So if I get, this is my viewing film. Hang on a sec. I'm gonna put the phone down a minute. Can't do this with one hand. Right. Right. If I take about 2 magnets off that stack, get them away from the damn thing without it grabbing me. Right. So if I put 2 magnets on there, right. I've got a space to mark, so they'll grab each other. So I'll put 2 magnets there, and I'll put 2 magnets. All these magnets is about 1, 2, 3, 4. Hang on, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 magnets there, right? Now, if I get my viewing film and I stick the viewing film on the magnets, you'll see the field. You'll see how high the field comes on the viewing film, and I'm about 10-15 millimeters. Oops, I'm not pointing the camera, am I? So as I lift it up, you'll see how far the field extends. Go to a smaller magnet, and you'll notice that the field is completely different shape. Right? Look at that ring around there. There's a tight, constrained ring. I'm trying to get the light on it properly. It's hard to see it. Oh, hang on. I'll get this light on it. Oh, got reflection on it now. Yeah, which is the best angle? I don't know if you can see that ring. Right, there's a tight ring around there, but if I bring that over to all these magnets, it's not the same. You'll notice the ring is not as tight. It's spread out. It's much taller, and yeah. So the more magnets you have, the higher the field goes, basically. On that one, it seems to be much more constrained. Don't know if you can see the difference. It's not quite the same. With more magnets, it goes a lot taller. You can get a lot further away from it. Whereas if I hold that at the same height, there, that's about 10-15 millimeters. It's hard to see it. I don't know why it doesn't show up so well on the camera, but it doesn't show up as well on the camera. But on that one, there's a bigger block area in the middle where it's collapsing more, and there's more white on there. Until I get closer to that one. When you get closer, it gets much more condensed. You get a much bigger white ring around it. Alright, let me just move that over there, because I want to get the same amount of light on both of them. I'll stick this on here. Right, look at the difference between that one. look at the difference between that one and that one. I moved it too far from the light now. It's hard to see it. Anyway, so having more coils, but it makes the flux travel further, basically, in a straight line. So it's about focus. Let me just see if I'm gonna put these magnets back on that stack, and I don't want to do it with one hand. It'll grab me. Hang on a sec. Right. It's pouring down rain out there. So what I'm trying to do is create two coil sets, and I'll be able to focus the field, because one section, with the bottom section of coils, for example, I could attenuate how much current goes through the base coil section. So the base coil section on here, I could have it at, I could adjust that, the amount of power going through that through a resistor or something, and attenuate it and focus it to optimize minimum current consumption. That is what I'm hoping to do. I want to affect that field. I wanted that field to be constrained or expanded. I want to tune it, and you can't do that with just one coil. You need some kind of focus arrangement. Now, there's another way, obviously, would be to move the coils, but I don't want to be doing that. You can simply do it by increasing or reducing power to one coil, so it would have the same effect as moving them closer and further apart, you know, up and down, basically. So if you look at cameras, I mean, they've got a lens that moves up and down. The lens goes up and down to focus the light and give you a nice sharp image. Well, you could do something very similar with a magnetic flux by adjusting and attenuating one coil when the other coil is permanently actuated, if you understand what I'm saying. So this is why I decided to use a double-decker coil system, but the bottom coil section has got magnets. So if I pull this all the way out, if I can pull this all the way out, it's just a bit stuck at the moment. Hang on a minute, I've got to use both hands again. It was a bit jammed up there. Right, I've taken it out. So there's the bottom coils down there. Take this out. Focus. Come on, focus. Right, so there's the bottom coils. If I lift one of them out. Oops, I've got a wire connecting on that one. I'll lift this one up. All the same. I've got my magnetic array in the base with a ball bearing down there. If you look, so the magnetic flux is being switched into being captured by this coil, and this flux is being added to the static magnetic flux is being added to the electromagnetic coil, and this being the first stage. And so I can tune that bottom section separately if I want to do. So it gives me much more control over the drive circuit than I would normally have. So this is the idea. I'll just pop that back in, and this just sits on top of that one, and then I stick the drawing to the unit in there. Nothing in there right now. So, and there's my cooling fan blowing air all the way through. Anyway, so just a little update on what's going on right now. I'm not rushing, I'm taking my time. I mean, it's very boring winding these coils. I'm doing 2 or 3 layers a day or something like that. So I mean I could do it all in one day if I really wanted to, but what with this arm problem, this tendonitis, I've kind of been taking it steady really, because I don't want that thing to plague me again. My arm does seem to be getting better though. The tendonitis seems to be going away slowly, and I want it to go away. I don't want to push it and then it come back, because every time I lift the kettle it's been giving me a lot of trouble. You know, when you go to make a cup of coffee and you lift the kettle up and you feel like your arm's about to fall off, you know, you feel like you're going to drop the kettle. That's the reason why I've been trying to take it slowly lately. So yeah, just winding away on this, and it's my self-guiding coil winder. Yeah, works great. Yeah, so anyway, that's it really. Nothing else to tell you at the moment, except I am sticking with the same diameter as the original coils, but the original ones were round, and also this one's got slots through. The bottom coils have got laminations in, but these don't, because I want some airflow to circulate through the plastic to keep things cool. And so I thought, well, I'm going to leave the same slots there, but I'm not going to put laminations in the top ones, because these usually get more power through them anyway. And there's little tiny holes at the sides there, just to let some airflow through there. When this fan's blowing, I'm hoping there's a big enough gap there that air can get past. There's a bit of a step. It's hard to show you this, but there is a step. There's a slight step there, just enough for some air to squeeze by and keep things cool, hopefully. Anyway, that's all for now. How long have I been going? 26, 16 minutes. I was looking at 26 frames per second. Yeah, 17 minutes nearly. So that's it. Thank you for watching. Give me a thumbs up or a thumbs down. I don't normally ask for that because, yeah, but it does help, you know. But I don't make any money out of my videos. None of my videos are monetized. But yeah, it just lets me know if people appreciate what I'm doing, you know. Otherwise I might disappear in a corner somewhere and sulk. Okay.